Let us start doing worksheet questions from quadratic equations. First question. Alpha and beta are the roots of the quadratic equation x square plus bx plus c is 0 such that alpha square plus beta square is 5 and alpha cube plus beta cube is 9. And what is b plus? What is sum of roots? Minus b by a, so minus b. Product of the roots c by a, so c. Alpha square plus beta square can be written as alpha plus beta whole square minus 2 alpha beta, which is given as 5. So b square minus 2c is equal to 5. Next, alpha cube plus beta cube can be written as alpha plus beta whole cube minus 3 alpha beta into alpha plus beta, which is 9. So this is minus b whole cube minus 3c into minus. So this is minus b cube plus 3bc is equal to 9. Now from this, what is c? B square minus 5 by 2. Substitute this value of c here, then you get minus b cube plus 3b into, in place of c, right, b square minus 5 by 2 is equal to 9. Simplify by taking LCM, then minus 2b cube plus 3b cube minus 15b is equal to 18, which implies b cube minus 15b is equal to 18. By trial and error method, b value will be minus 3. By trial and error method, b minus 3 satisfies this equation. If b is minus 3, what is c? Substitute here. b minus 3 implies c is equal to 9 minus 5, 4 by 2, 2. Therefore, what is b plus c? Minus 1. Option B. F of x is given, g of x is given. F of 2 minus g of 2 is 1. That 1 I can write it as 2 minus 1 whole square. F of 3 minus g of 3 is given as 4. That 4 is nothing but 3 minus 1 whole square. F of 4 minus g of 4 is 9. That 9 can be written as 4 minus 1 whole square. So by looking all this, we can say that f of x minus g of x is equal to x minus 1 whole square. Now what is the question? Root of f of x minus g of x, 0. So root of f of x minus g of x is equal to 0. That is x minus 1 whole square is equal to 0. Implies x is equal to 1 is the root. Option A is correct. Here key is given wrong. So the correct answer is option A. Next, alpha and beta are the roots of that quadratic equation. So let us find roots for that. Minus b plus or minus root of b square minus 4ac by 2a. So this is nothing but 2 plus or minus root minus 4. Root minus 4 is 2i. So this is 2 plus or minus 2i by 2, which means 1 plus or minus I. So alpha is 1 plus I, beta is 1 minus I. Now we have to find 1 plus I whole power 2020 plus 1 minus I whole power 2020. For that there is a shortcut formula like this. A plus IB whole power n plus A minus IB whole power n is equal to 2 into A square plus B square whole power n by 2 into cos of n tan inverse V by A. This is a shortcut formula for this. For us, A and B are 1 and 1. Because A plus IB is 1 plus I for us, A1, B1. So 2 into 1 square plus 1 square whole power n by 2 is 1010 because n is 2020 into cos of 2020 tan inverse B by A is 1. So this is nothing but 2 into 2 power 1010. So 1011 into cos of tan inverse 1 is 5 by 4. So 2020 into 5 by 4. And what you get? 2 power 1011 into cos of 505 pi. So that is 2 power 1001 into cos of 505 is minus 1. So minus 2 power 1011. For that, I am giving a formula. Cos n pi is nothing but minus 1 whole power n, where n is integer. Okay. Then what is cos 505 pi? Minus 1 power 505. 1 power 505. So minus 1. So like that you get minus. So option B. Next to the quadratic expression given is minus x square plus 6x plus 12. This expression attains extreme value beta at x is equal to alpha. We have a formula like this. Ax square plus bx plus c has extreme value at x is equal to minus b by 2a, and that extreme value is nothing but 4ac minus b square by 4. So here for us a is minus 1, b is 6, c is 12. So it has extreme value at alpha. So what is alpha? Minus b by 2a, which means minus 6 by minus 2, 3. And the extreme value at alpha is equal to minus b by 2. And that extreme value is nothing but, 4ac, 4ac minus b square, 36 by 4a. So after simplification, what you get? Minus 24 minus 60 by minus 4, 60 by 4, 15. This is beta. I got beta 15, alpha 3, which means beta is equal to 5 times alpha, because 15 is 5 times of 3, so option B is correct. Sorry, here 4AC, C is 12. So minus 48 minus 74 by 4, 4AC, 4 into minus 1 into 12 minus b square is 36 by 4a is again minus. So minus 48 minus 36 minus 84 by minus 4, which is 12. So beta is 12. Sorry, 21. So 21 is 7 times of 3. So beta is equal to 7 alpha. Option A is correct. Next, when b is equal to 17, it is found that roots of the equation are minus 2 and minus 15. So what is sum of the roots? Minus b, which is minus 17. So b 17, that is already given. Next, product of roots c by a, which is c, which is minus 2 into minus 15, 30. Now, if alpha beta are the roots of the same equation, so tell me the equation now. When b is equal to 13, so x square plus Now B is 13 for us. C is 13. Now we have to find difference between the roots. The formula for difference between the roots is under root b square minus 4ac by mod a. B square is 169. 4 into 30. 120 by mod a is 1. So root 49, which is 7. Option A. Now, alpha, beta, gamma are the roots of the cubic equation. 5x cubed minus 2x minus 4 is equal to 0. Divide this 5 with 5. And the question is finding alpha cube plus beta cube plus gamma cube. Compare this with the standard equation x cube minus s1x square plus s2x minus s3 is equal to 0. From that you will get s1 as 0, s2 as minus 2 by 5, s3 as 4 by 5. And the question is finding alpha cube plus beta cube plus gamma cube. For that the formula is s1 cube minus 3 s1 s2 plus s1 s3. Sorry, 3s3. Now substitute s1 s2 s3 values there. X cube minus 3s1 s2 plus 3s3. S1 cube 0, 0, 3 into 4 by 5. So answer is 12 by 5, option A. Next. In equation is given x square minus 5x minus 14 is greater than 0. And x lies outside alpha beta, then what is alpha beta? Now write factors for this. Plus 2x minus 7x minus 14 greater than 0. X into x plus 2 minus 7 into x plus 2. So this is x plus 2 into x minus 7. Now if alpha is less than beta and x minus alpha into x minus beta is greater than 0, then x is less than alpha or x is greater than beta. Here alpha is minus 2. So x is less than minus 2 or x greater than 7, which means x doesn't lie between minus 2 and 7. So x lies outside of which interval? Closed interval minus 2 comma 7. See, x less than minus 2 or greater than 7 means x doesn't lie between minus 2 and 7. So compare this with the given interval. You get alpha as minus 2, beta as 7. Therefore, alpha by beta is nothing but minus 2 by 7. Option A. Next, there is small correction in the question. X is equal to 2 plus 2 power 2 by 3 plus 2 power 1 by 3. That should be in denominator. I mean, it's not in the power. Look here, 2 plus 2 power 1 by 2 power 2 by 3 plus 2 power 1 by 3 should be written like this. That is small mistake. Then what is x cube minus 6x square plus x? Bring 2 this side. X minus 2 is equal to 2 power 2 by 3 plus 2 power 1 by 3. Cubing on both sides. X minus 2 whole cube is equal to 2 power 2 by 3 plus 2 power 1 by 3 whole cube. A minus b whole cube, a cube minus b cube minus 3a square b plus 3ab square. Similarly here a cube is 2 power 2 by 3 whole cube, which is 4. B cube is 2. A cube plus b cube plus 3ab, into a plus b. A plus B whole cube is A cube plus B cube plus 3AB into A. That's what I wrote. So this is x cube minus 6x square plus 12x minus 8 is equal to 4 plus 2 is 6. 2 power 2 by 3 into 2 power 1 by 3 is 2 into 3. 6. In place of this, I can write x minus 2. X cube minus 6x square plus 12x minus 8 is equal to 6 plus 6x minus 12. Now bring all terms to one side. 12x minus 6x plus 4 is equal to 0, or x cube minus 8, sorry, minus 8 minus 2 is equal to 0. So x cube minus 6x square plus 6x is equal to 2, option B. Next, f of x is ax square plus bx plus c, and the greatest common divisor of abc is 1. One root is given, let us say it is alpha, minus 7 plus. We know that complex roots always occurs as conjugate base. So the other root will be minus 7 minus root 11i by 6. One root is given, so you can find other root. Therefore, what is sum of the roots? Minus 14 by 6 minus 7 by 3. Product of the roots, if you multiply both the roots, a plus b into a minus b, a square minus 11 into I square by 6 into 6, 36. So this is I square is minus 1. So this is 5 by 3. Therefore, what is the equation? What is f of x? Sum of roots, product of roots are known. So the quadratic equation formula is x square minus sum of the roots into x plus product of the roots is equal to 0, which means f of x is equal to 0 implies 3x square plus 7x plus 5 is equal to 0. That is f of x. Now what is the condition given for us? F of x by k minus L is x plus 4 into 3x minus 5. X plus 4 into 3x minus 5. How to get f of x by k? Replace x with x by k in this. So this is 3 into x square by k square, 7 into x by k plus 5 minus L is equal. By multiplying these two factors, you get 3x square plus 7x, you get minus 20. Now compare these two and tell me what is k. By comparing those two, k will be 1 and 5 minus L is equal to minus 20. Constant term. By comparing constants on both sides, 5 minus L is a constant term here, minus 20 is a constant term. So from this, what will be L? 25. So L is 25, K is 1. 1 comma 25, option B. Now alpha by alpha plus 1 and beta by beta plus 1 are the roots of the quadratic equation given. Now the question is equation having roots alpha and beta. See, equation having roots alpha and beta is nothing but f of x by x plus 1 is equal to 0. Because alpha by alpha plus 1, beta by beta plus 1 are the roots of the quadratic equation. So what is f of x? F of x is x square plus 7x plus 3. And we require the equation whose roots are alpha and beta, which is f of x by x plus 1 is equal to 0. So replace x with x by x plus 1. Take LCM and do cross multiplication. You get x square plus 7x into x plus 1 plus 3 into x plus 1 whole square. If you expand all the terms, here you get 3x square, 7x square. 3x square plus 7x square, 10x square plus 1, 11x square. Here you get 6x, here you get 6x, here you get 7x, 13x, and the constant term will be 3. 11x square plus 13x plus 3 0, option B. Next, P and Q are the roots of the given quadratic equation. 3p by 1 minus 2p, 3q by 1 minus 2q are the roots of, I think it should be Lx square plus mx plus 1. And the greatest common divisor of Lmn is 1, then what is L minus n plus 1? This should be done like this. Let y is equal to either 3p by 1 minus 2p or 3q by 1 minus 2q. Take any one as y, do cross multiplication, or y is equal to take p common. So what is p from this? Y by 2y plus 3. Now, p is a root of which equation? Given equation. P is a root of x square plus 7x plus 3 is equal to 0. Implies in place of x I can write. Now what is p we got? Y by 2y plus. So y square by 2y plus 3 whole square plus 7 into y by 2y plus 3 plus 3 is equal to 0. Take LCM and simplify. Then what you get? Y square plus 7y into 2y plus 3 after taking LCM plus 3 into 2y plus 3 whole square is equal to 0. Now expand and simplify this, and what is the y square you get? 14y square here, 15y square, 12, 27y square after expanding all the terms. Then what is the y you get? 21y here, 36, 21 plus 36, 36, 21, 57y, yeah? 57y, constant term 27. I think you can cancel it 3, so 9y square plus 19y plus 9 is equal to 0. Now this is given as Lx square. So L is equal to 9, M is equal to 19, N is equal to 9. Therefore, what is L minus M plus N? Minus. Option C. Next. S is the set of all possible integral values of lambda in the interval minus 3, 7 for which roots of the quadratic equation are all rational numbers. X is missing here. Roots are rational numbers. Roots are rational number implies discriminant should be a perfect square. Discriminant should be a perfect square. So what is discriminant here? B square minus 4AC. This should be a perfect square. For this to be perfect square, what should be the value of lambda? That we have to do by trial and error method. Given that values of lambda are in the interval minus 3, 7. Lambda is equal to 0. If lambda is 0, then this becomes 169, which is a perfect square. The values of lambda should lie in the interval minus 3, 7. So you need to check the values from minus 3 to 7. So for 0, it is correct. Again, for if it is 6, lambda is 6, 28, 6 is 144. 169 minus 144 is 25. 25 is a perfect square. Next, another value for lambda will be minus 2. Because if lambda is minus 2, 169 plus 56, 225, which is a perfect square. So I got three values for lambda. Then what is sum of all these values? 4. When you add all those, you get 4. Option A. Next, if x is real number, then the interval in which no value of the expression lies. First, consider this as y, do cross multiplication and bring all the terms to one side. So 2x square, 4 minus 2y into x plus 5y minus 22 is equal to 0. Now, given that x is real, since x is real, discriminant is greater than or equal to 0, implies b square minus 4ac is greater than or equal to 0. 16 plus 4y square minus 16y minus 40y plus 88 is greater than or equal to 0. So 4y square minus 56y plus 104 is greater than or equal to 0. You can divide with 4. Y square minus 14y plus 26. Now let us write factors for this. 170, 176, this is 176. So 176 plus 16, 192. If we divide with 4, 48. And if you write factors for this, y square minus 14y plus 48, y minus 6 into y minus 8 greater than or equal to 0, which means y less than or equal to 6 or y greater than or equal to 8. So y doesn't lie between 6 and 8. Y doesn't lie between 6 and 8. So what is the interval in which the expression doesn't lie means? So open interval 6 comma 8. Option D. Next, the set of values of a for which the expression assumes all real values for real values of x. Let us say the given expression is y. Given that expression assumes all real values for all real values of x. Do cross multiplication and bring all the terms to one side. Then you get a quadratic expression like this: a plus 3y into x square minus of 2 plus 2y into x plus 3 minus ay is equal to 0. Consider the given expression as y, do cross multiplication, bring all the terms to one side. Since x is real, we know that discriminant is greater than or equal to 0, which means b square minus 4ac greater than or equal to 0. If you apply that, if you apply discriminant greater than or equal to 0, then you get like this: 3a plus 1 into y square plus a square minus 7 into y plus 1 minus 3 greater than or equal to 0. This is what you get by applying discriminant greater than or equal to 0. In the question, it is given that x is real as well as y is also real. So since y is real and this expression is positive, look here, this expression is positive. Expression is positive and all y real given, then discriminant will be less than or equal to 0. By applying discriminant for this quadratic expression, then you get a power 4 plus 22a square plus 45 less than or equal to 0. See, a power 4 and a square is always positive. So this expression is always positive. It cannot be less than 0, which means a belongs to null set. Because for no value of a, this expression will be less than 0 because a square, a power 4, everything is positive. So there is no value of a where the expression becomes less than or equal to 0. So option C is correct, but key is given wrong here. The correct answer is option C. Next, k is a real number, then the roots of this quadratic equation are always. Multiply those two factors, you'll get x square minus 5x plus 6 minus k square is equal to 0. Now, if you look at the options, you have to find nature of the roots. Already we discussed. Nature of the root depends upon the discriminant b square minus 4ac. 25 minus 4 into 1 into 6 minus k square. So this is 25 minus 24 plus 4k square. 1 plus 4k square. How 1 plus 4k square will be always positive? Delta greater than 0 means roots are real and distinct. So to find nature of the roots, remember you have to find distinct. Roots are real and distinct means option A. Next, alpha and beta are the roots of ax square plus bx plus c0. And there is a small correction. This is px, second quadratic equation is px square, not b. For this equation, the roots are 1 by alpha minus 1 and 1 by beta minus 1. Then what is the value of r? That is the question. Let us say the first quadratic equation is denoted with f of x. So what are the roots of f of x0 given alpha beta? If roots of f of x is equal to 0 or alpha beta, then what is the equation whose roots are 1 by alpha and 1 by beta? F of 1 by x is equal to 0. Now find f of 1 by x. A by x square, b by x plus c is equal to 0. Simplify this, then you get cx square plus bx plus a is equal to 0. For this equation, what are the roots? 1 by alpha and 1 by beta. But what is the equation required for us? For this equation, the roots are 1 by alpha minus 1, 1 by beta minus 1. Then, how to get the equation whose roots are 1 by alpha minus 1 and 1 by beta minus 1. Let us say this is some g of x. To get this equation, you have to replace x with x plus 1. So g of x plus 1 is equal to 0. Now, how to get g of x plus 1? Replace x with x plus 1. So c into x plus 1 whole square, b into x plus 1 plus a. So this is cx square, 2cx plus bx, 2c plus b into x, constant, c plus b plus a. So this is the equation whose roots are, for this equation the roots are 1 by alpha minus 1, 1 by beta minus 1. But this equation is given as px square plus qx plus r is equal to 0. And what is the value of r? By comparison, a plus b plus c, option C. Next, alpha beta are the roots of x square minus x plus 1, 0. We know that roots of x square plus x plus 1 is equal to 0 are minus omega and minus omega square, which are cube roots of unity. So alpha is minus omega, beta is minus omega square. And what is required? Alpha power 2015. What is alpha power 2015? Minus omega power 2015. 2015 is odd number, so minus. How to find omega power larger numbers? Divide that number with 3 and write down the remainder in the power of omega. If you divide with 3, 3 6 is 18, 21, 3 sevens. So remainder is 2. And what is beta power 2015? Minus omega square whole power 2015. This is again minus omega power 4030. Divide that number with 3. remainder is 1, so minus omega. So the required equation is again, what is the required equation? It is the equation whose roots are minus omega and minus omega square, which is nothing but x square minus x plus 1 is equal to 0. Option A. And K is given wrongly. Option A is the correct answer. So again here, the quadratic equation is given as x square plus x plus 1 0. And we know that roots of this equation are omega and omega square. Therefore, alpha is omega, beta is omega square. Then alpha power 4, omega power 4, beta power 4, omega power 8, alpha power minus 4, 1 by omega power 4. This is 1 by omega power 8. Omega power 4 is nothing but omega. Divide this number with 3 and write down the remainder. This is omega square, 1 by omega into 1 by omega square. Omega plus omega square is minus 1. Omega cube is 1. Final answer will be 0. Option A. Next, alpha and beta are non-real cube roots of 2. So alpha and beta are cube roots of 2, which means alpha cube is 2, beta cube is also 2. Alpha cube root 2, beta is also cube root 2, which means alpha cube is 2, beta cube is 2. So what is alpha power 6 plus beta power 6? 4 plus 4, 8 is the correct answer, but key is given wrong. Correct answer is 8, option A. Next, the solution set of mod x whole square minus 5 mod x plus 4 less than 0. Let mod x is equal to some t. So t square minus 5t plus 4 is less than 0. Write factors t minus 1 into t minus 4 less than 0, which means t lies between 1 and 4. T is nothing but mod x. So from this, mod x is greater than 1 and mod x is less than 4. Mod x less than 4 means x lies between minus 4 and 4. Mod x greater than 1 means x is less than minus 1 or x is greater than 1. Now draw the number line and this is minus 1, 1, 4, minus 4. And the end value minus infinity and this is somewhere plus infinity. What is the first condition? X is less than minus 1, x is greater than 1. Shade like this. Less than minus 1 means up to minus infinity, greater than 1 means up to plus infinity. Second condition is x lies between minus 4 and 4. Shade like this. And see where both the intervals are getting overlapped. So what is the intersection of both the intervals? Minus 4 to minus 1, union 1 to 4. Option C. Intersection of both the intervals, minus 4 to minus 1 and 1 to 4. Option C. Next, x square plus px plus 1 is a factor of ax cube plus bx plus c. Therefore, this should be written as x square plus px plus 1 is one of the factor. Since left hand side is cubic, the other factor should be some ax plus c. Why? Because we should get ax cube. So for that, x square should be multiplied with ax. So the other factor is ax plus c. Now you have to find relation between a square b square. Now multiply here ax cube cx square apx square pcx plus ax plus c. So this is nothing but ax cube ap plus c into x square a plus pc into x plus c. Now by comparing these two, what will be b? ap plus c. and a plus bc must be 0 because there is no, sorry, a plus bc is b, ap plus c is 0 because there is no coefficient of x square. By comparing x square coefficients on both sides, right hand side ap plus c, left hand side 0. So this is one condition. By comparing x coefficients, ap plus c is x coefficient in right hand side, left hand side is b. Now we have to eliminate p. What is p from this? Because in options there is no p. So what is p from this? Minus c by a. Substitute that p here. So a plus p into minus c by a is equal to b. That implies a square minus pc is equal to ab you will get. Let's simplify that directly, you will get the relation. A square minus pc is equal to ab. Sorry, we have to eliminate p, right? Eliminate p, which means a plus in place of p minus c by a. This implies a square minus c square is equal to ab. Option D is the correct answer. Next, f of x is ax square plus bx plus c, satisfying f of 1 plus 2f of 2 is equal to 0. 2f of 1 plus f of 2 is equal to 0. Then what is 3a plus b? Subtract these two. Subtracting these two, 2f of 2 minus f of 2, f of 2, f of 1 minus 2f of 1 minus f of 1 is equal to 0. What is f of 2? Put x is equal to 2 in this. F of 2 will be 4a plus 2b plus c. F of 1 will be a plus b plus c, which is 0. Simplify this, 4a minus a, 3a, 2b minus b, c gets cancelled. So 3a plus b is equal to 0, option C. Next, there is a correction in this question. Alpha and beta are the roots of that quadratic equation. And alpha n is, sorry, that is an. An, this is an. An is equal to alpha power n minus beta power n. And one more correction is, the question is finding the value of a10 minus 8a8 by 5a9. This is wrong. Okay. a10 minus 8 into a8 by 5 into a9 is the value required for us. What is a10? Alpha power 10 minus beta power 10. a8 alpha power 8 minus beta power 8 by a9 alpha power 9 minus beta power 9. In numerator, if I take alpha power 8 common, then what I get? Alpha square minus 8. Similarly, take minus beta power 8 common, again you get beta square minus 8 by 5 into alpha power n minus beta power n. Now, alpha is the root of given equation, means in place of x I can put alpha. So alpha square minus 10 alpha is equal to 8. Similarly, beta square minus 10 beta is equal to 8. Therefore, what is alpha square minus 8 here? 10 alpha. Beta square minus 8, 10 beta. Now substitute those values here. So alpha power 8 into 10 alpha minus beta power 8 into 10 beta by 5 into alpha power 9 minus beta power 9. So what is common in numerator? 10 is common. Alpha power 8 into alpha. Alpha power 9 minus by. So this term gets cancelled. Answer will be 2. Option D. So there are so many corrections. So the number of positive real roots of the equation. Write 3 power x plus 1 as 3 power x into 3. 3 power 1 minus x as 3 by 3 power x is equal to 10. Now let 3 power x is equal to some t. Therefore 3t plus 3 by t is equal to 10, or 3t square minus 10t plus 3 is equal to 0. Write factors. Dt into t minus 3 minus 1 into t minus 3. So from this, what are the values of t you get? T is equal to 3, t is equal to 1 by 3. T is nothing but 3 power x. So 3 power x is equal to 3. 1 by 3 can be written as 3 power minus 1. So I got x is equal to 1 as one value. So altogether I got two roots, but the question is number of positive real roots. I have only one positive real root. So answer is option C. He is given wrong. Option C is correct. Next, the sum of real roots of the equation. Take mod of x minus 2 is equal to some t. Then given equation becomes t square plus t minus 2 is equal to 0. If you write factors, you get t plus 2 into t minus 1 is equal to 0. You get two values for t minus 2. But what is t? Mod of x minus 2. Modulus can never be negative. So there is no meaning in saying t minus 2. Now mod of x minus 2 is 1. If I remove modulus, I should write plus or minus. X minus 2 is equal to 1. So from this I get x is equal to 3. From this I get x is equal to 1. So number of real roots are 2. But the question is sum of real roots 4. 3 plus 1. Here also k is given wrong. Answer is option A. Next, for what values of a belongs to z, the expression x plus a into x plus 1991 can be factorized as x plus b into x plus c, which means for this equation, given that b and c are integers, so root indirectly the question is for this equation to have integral roots, what values of a are possible. So this equation should have integral roots. X plus a into x plus 1991 is equal to minus. See, given that a is an integer and integral roots means x should also be integer. So if x is integer and a is integer, this is an integer and this is an integer. Product of two integers minus 1 means there are two possibilities. X plus a 1 and x plus 1991 should be minus 1. This is one possibility. Or x plus a minus 1 and x plus 1991 should be 1. These are the only two possibilities. From this, what is x? Minus 1992. Then what will be a from this? 1 minus x, so 1993. Here I got one value. Similarly here, what will be x? Minus 1990. Then what will be a? Minus 1 minus x, so 1989. So for what values are means there are two values for a, 1993 and 1989, out of which 1989 is given. So option B is correct. Again, there is no correct answer. Okay. Both are correct. 1993, 1989. So option B is correct.